Hi and welcome back. Let's look at deleting nodes from a binary tree when they have two children. So when the toDelete node has two children, we must do something a bit special. Let me bring up my diagram once again. We've looked at this before, just a quick recap. Let's say we want to delete the node 9. What we must do is find the rightmost node in the left branch, so 8, or, if you prefer, the leftmost node in the right branch, 11. Because we've coded a find rightmost, we're going to stick to that. We're going to use 8 in this case, but you can use 11 if you prefer. So we're going to find the rightmost node in the left branch. We will also need its parent, because the parent will have to point to the children. Okay? Something that we know is that the rightmost node in this branch has nothing to its right. Okay, hopefully that makes sense. The rightmost node in this branch doesn't have anything to its right, because if it did, that would be the rightmost. So when you go as far right as you can, this node has either 0 or 1 children, not 2. Okay? So that is important because as part of deleting 9, we are going to have to delete 8, essentially. We're going to move 8 up here, which means that 7 has to point down here. Like that. So essentially we've deleted 8, and if 8 had 2 children, this would get extremely complicated. Because we'd be deleting a node of 2 children by deleting another node of 2 children. This is quite simple. If 7.5 had other children, this would be fine, because 7 points to 7.5, 7.5 children stay there. So that's okay. And of course, if 8 has no children, then that's fine. We don't have to worry about it. So no problem. Let's start with this scenario. The scenario where we want to delete, say, 9, and that has a node in this structure here. So the first thing we have to do is see whether the node we want to delete is at the left or at the right of its parent. Okay? So if toDelete equal toDelete parent left, let's say. I'm going to delete this pass, by the way. Elif toDelete is equal to toDelete parent right. And of course, else, what happens when they're the same? When you want to delete the root and it has 2 children. Now, for all of these, we're going to need the rightmost node in the left branch. So we're going to say rightmost equal self.find rightmost of toDelete left. Okay. And rightmost parent is going to be self.find parent of the rightmost's value. Once again, find parent, which is up here, takes in a value and sort of goes to the tree and tells us what the parent is of the value we're looking for. So here we've got the rightmost node in the left branch, and we've also got the rightmost parent of that node. We know that it is a rightmost node because there is a left branch. toDelete left returned true, or it wasn't none, so we know that this is not going to be none. So therefore this is fine. Accessing rightmost value like that without checking or without catching any exceptions is okay, because rightmost value will return something. We know that because we have 2 children. Okay? Now, if we want to delete something on the left, what do we have to do? Let's go back to the diagram. Let's say we want to delete, let's start with the right one. Let's say we want to delete 9. So the first thing we have to do is find out 8, which we've done that. We've done the rightmost node. Then we have to say the rightmost node's right now has to be equal to 12, right? If 8 is going to replace 9, 8's right must be what used to be 9's right. Let's start with that. Rightmost right has to be equal to toDelete right. Okay? So that means that the rightmost node here, 8, is going to replace 9 by pointing at 12. The toDelete's parent now no longer has to point at 9. It has to point at 8. So toDelete's parent has to point to the rightmost node. Let's do that. toDelete parent right equal rightmost. And by the way, I apologize profusely. We said we were going to do the right first, so that's there. If you wanted to do the left, it would be exactly the same, but this would be in the left. Okay. So we found that the rightmost node's right must point to what used to be the toDelete's right. So 8 is going to point to 12. toDelete parent right has to point to 8 because toDelete is equal to toDelete's right. So we're deleting 9, therefore the parent's right has to point somewhere else. If we had another 2-child node here on the left, it would be this left that has to point somewhere else. So that is what this is doing.